Alright, so we're going to start chapter 10 with this video, and chapter 10 is a little bit different than a lot of the other videos you've seen. Most of algebra deals with variables and things like that, and chapter 10 really doesn't have to deal with that much at all. It's what we call our probability chapter in some ways. Basically what we're going to be doing is finding the probability of doing this, or how many different ways can this happen. Maybe you've seen this before, and some of this stuff will be really easy for you. Some of it may be a little bit more challenging. It's just one of those things that the terminology sometimes gets a little bit confused and messed up. So you are going to have to make sure that you understand what the terms mean and try and follow along the best that you can. Just make sure that you ask questions, jot things down if there's something that confuses you, so that way you can bring it to class. I don't think this video will take that long, but we will do the best that we can. So our vocabulary for this is, the first one is a permutation, and that's a new word for pretty much all of you, is an ordering of n objects. Okay, and we'll talk about that a little bit later. And then it says, for any positive integer n, the product of all the integers from 1 to n is called the factorial. And that's probably a new term for most of you. So let's get done with the easy stuff first. The first thing that we're going to talk about is our counting, like how we count things. Now, there are questions like this on the ACT all the time. So it says, oftentimes we want to count the number of possible ways to perform a task. One way to do this is by making a tree diagram. So basically what we're looking at is a sporting goods store offers 3 types of snowboards, okay, and then 2 types of boots, and then it wants to know, okay, how many choices does the store offer for snowboarding equipment. So we have 3 types of snowboards, 2 types of boots, and basically what happens is you can take a tree diagram and say, okay, we want the all-mountain snowboard, and then that can be paired with a soft or hybrid type of boot. Then we go to freestyle, offers 2. Carving offers 2. So when you count everything, we have 1, 2, 3, 4, 5, 6. So we have 6 possible combinations is what we call it. Now there is a better way to do that, and it's called the counting principle. And all you do is you just multiply the number of choices that you have. So if we have 2 events, in this case up here, it was the type of snowboard. We have 3. Over here, the type of boot, we had 2 types of boot. So if we just do the number of choices here, the number of choices here, multiply them, you get 6, okay, which is why you got 6 up here. Just a little bit easier to just multiply them to get your 6. Okay, so the same thing is true as if you have 3 or more events. If you have 3 events, then you're just going to multiply all 3. If you have 4 events, you're going to multiply all 4. So literally, it's just, they're all independent type choices, so you just multiply it all the way through. So what I want you to do is real quickly go through and do 1, 2, and 3 and hit play when you're ready. I'm going to go through these very, very quickly because this should be pretty simple. All right, so for this first one with the blood drive, you should have gotten 16. You have 4 types, you have 2 factors, and then you have one or the other for a gender. So it's just 4 times 2 times 2. So you have 16 different combinations of ways that blood can be labeled. The second one, you should have gotten 105. So the different choices that you have for each kind of book, you have 105 different combinations of mixing up your novels, books of nonfiction, and comic books. And then the last one for the pizza, you have 3 times 4 times 5 times 8 is 480. So again, that means that you have 480 different combinations of choosing one of each. Okay, so if you're choosing more than one, that would change things quite a bit. But this is if you're only choosing one of each. 3 times 4 times 5 times 8. Okay, so hopefully that makes sense. Let's move on. All right, so the next part is we're going to start talking about permutations. So it says repetition involves using the same digit or letter or whatever we're doing more than once. For any given situation, the number of choices with repetition is greater than the number without repetition. In other words, sometimes when we choose something, we can't choose it anymore. So like if you pick a card out of a deck and you don't put it back in the deck, then that lowers the number of choices that you have the second time. But sometimes we do put that card back in the deck, and if you do, then you're going to have the same number each time. For example, a town has telephone numbers that all begin with 329 followed by 4 digits. Okay, so every one of us has 4 digits to end our phone number. It says how many different phone numbers are possible if the numbers can be repeated. And that's true in all of our cases. You can have a phone number that is 0000. That's not a problem. So the point is that when you do this, if you're able to repeat your number, then you have 10 choices, 0 all the way up to 9. That's 10 choices for each digit. So that's basically the same counting principle we did before, and we have 10 each time. So we do 10 times 10 4 times, and that gives us 10,000 choices. And if you think about it, that makes sense. If you go from 0000 all the way up to 9999, that's 10,000 choices. But in the rare occurrence where you cannot replace a number, it's still easy, but it's a little bit different, because the first time you pick a number, you have 10 choices. But then we don't have all 10 anymore because we can't repeat. So then the second choice, we only have 9. The third one, we only have 8. And then the fourth one, we only have 7. So we multiply those 4. And you get a quite a bit smaller number. It's almost half. So now if you're not able to repeat, you actually only have 5,040 choices instead. So you want to be real careful there about what the question is asking on whether things can be repeated or not. Okay, so basically what we're talking about here is we're talking about permutations. The first one with the counting principle is called combinations. Combinations means order doesn't matter. There's no repeating, or you can repeat, so that doesn't really matter. With permutations, the order matters, and you don't really want to repeat most of the time. So what happens is you usually are subtracting one off each time. Now, with a permutation, we use something called factorial. So what you see here is you see that if I wanted to do 3 times 2 times 1 in this case right here, so we have 6 permutations of the letters A, B, and C. So what's happening is we have 3 choices, 3, and then 2, and then 1, 3 times 2 times 1. What you will see is if you ever see something like this, 3 times 2 times 1, you will also see it written with a exclamation point. 3 exclamation point. That is factorial. What that means is exactly what you see down here. It's 3 times 2 times 1. So if I had 5 factorial, it would be 5 times 4 times 3 all the way until you get to 1. So these examples over here real quick, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1, and you just multiply that out and you get 5,040. And then if you were to do 8 factorial, that would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So in a sense, it's actually just 8 times whatever this number is right here. And you would actually get 40,320. Okay? So that's factorial. That's important for you to know that with a lot of the formulas that we're going to look at. Okay, so let's look at what I want you guys to do is, now that I've gone through those examples, I just want you to go ahead and do these problems up here on your own. Okay, this is dealing with this telephone number problem up here. So do 4 and 5 on your own and then hit play when you're ready. All right, so hopefully these were pretty easy. The first one, because they can be repeated, it's just 5 digits times itself 4 times, you get 625. The second one, because they can't be repeated, you have 5 to choose from, then 4, then 3, then 2, so you only get 120. So you can see the difference between combinations there pretty easily. Okay, number 5 is 7-digit telephone numbers, and they can be repeated. So we have 10 choices for digits each time. So it's basically 10 to the 7th, which is 10 million different orders that we can, or different phone numbers that we can have. But those numbers can be repeated. So that's going to be quite a bit more. Okay, so let's move on. We talked about permutations and what factorial is. So let's get right into an example of, this is going to be a little bit different, but it does involve factorial. So we're talking about a playoffs, and it says 8 teams are competing in a baseball playoff. What it wants to know is the first one is, it says, in how many different ways can the baseball teams finish the competition? In other words, like, how many ways can, like, one team come in first place, another team come in second place, third place, fourth place, you know, and how many different orders can we do? Well, the point is that we have literally 8 factorial different ways, because you have 8 choices for first place, then you have 7 choices for second place, then you have 6 choices for third place, so you do 8 factorial all the way down. So that ends up being 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we actually already did 8 factorial above, and you get 40,320. So that's that one. Now, the second question is a little bit different, and that's what we want to get into. This is where it gets a little bit trickier. It says, in how many different ways can 3 of the baseball teams finish first, second, and third? Well, we're only worried about 3 of them now. So we don't need to go all the way down. We just want to know how many different ways can we get first, second, and third. Well, it says any of the 8 teams can come in first. Then any of the 7 remaining teams can come in second, and then any of the remaining 6 teams can come in third. So now we've just made this a lot smaller, because now it's just 8 times 7 times 6. We don't need to do it all the way down, because we're only worried about the first 3. We're only choosing 3 in a sense there. And when you multiply those 3 together, you have 336 different ways that 8 teams can come in first, second, or third. Okay, so what I want you to do is do number 8 and number 9 on your own, and then hit play when you're ready. So these should have been really easy for you, considering they're the same as this example over here. We have the first one, we have 8 different news stories. Okay, how many different ways? Well, it's just 8 factorial. 8 times 7 times 6 times 5 times 4 times 3 times 1, and you get times 2 times 1, and you get 40,320. The second one, because we only want 3 stories, it's going to be 8 stories to choose in the first one, 7 to choose for the second one, and then 6 to choose for the third one. So you're only going to have 336 different ways to present those. Okay, so let's move on to the last page. Okay, so this is where it gets a little bit trickier. So we just talked a little bit about basically what this key concept right here is what we just did on the previous page. We have a little n and then p and then r, and this is permutations. So this is where we're going to actually we're going to take a certain number from a group. What I call this is n choose r. Makes it easier. N is the total number of objects, and we're going to choose r of them. And then this is the formula that we're going to use. In other words, n will be factorial on top, and then what we'll do is we'll do n minus r on the bottom, and whatever the difference is we'll do the factorial on the bottom. So let's get right into this example right here. So we're burning a CD, we have 12 songs, and we want only 4 of them. So because you only want 4 of them, what we're going to do is we're going to set this up. I call this 12 choose 4. Okay, that helps me know what type of permutation I need to do. So that means the 12 is on the left, the 4 is on the right, which means we'll have 12 factorial on the top. Then we'll do 12 minus 4 on the bottom to get 8. So we have 12 factorial on top, which equals 479,100,600. And on the bottom we have 8 factorial, which is 40,320. We divide those two numbers. It means that you have 11,880 different ways that you can put these 4 songs on the CD. Okay, so that's actually kind of a cool thing to be able to do in talking about how many different ways you can set that up. Okay, so let's go down to the next example. The next example is very similar, and I want to just walk through this. So we have 6 homework assignments, and we can only have time to do 4 of them. Okay, very, very, very common with you guys, I'm sure, where you only have time to do a certain number. So because we have 6 of them, I say this is 6, and we're going to only choose 4 of them to do. So we want to know how many different ways can we do 4 of those assignments. So we do 6 factorial on top. We do 6 minus 2 on the, 6 minus 4 on the bottom. So we have 6 factorial over 2 factorial, and that actually gives us 6 factorial on top is 720, and 2 factorial is 2. You divide that, you get 360. Okay? So that means that you can complete the 4 assignments and in 360 different orders. So it's not just about which 4 assignments you're doing. Because we're doing permutations, order matters. So assignment, if we just labeled it as assignment 1, 2, 3, and 4, that is one order. But if you did it 4, 3, 2, 1, that is a separate order. That's why there's so many. That's why there's so many different ways that you can do it in different orders. Okay, what I want you guys to do is, this video is going to be done because we're running out of time, and just go to part 2, and that will only take about 5 minutes at most to finish this up.